So let's get started. Good morning, everyone. My name is Joseph Amsili with New York Soil Health. It's a pleasure to be here with everyone virtually. It would have been great to be in person at Empire Farm Days, but unfortunately, due to COVID-19, we had to shift our organizing and make this event online. So I guess the potential possibility that some people that wouldn't have made it to Empire Farm Days can be here today. So that's a positive. This event was organized by New York Soil Health and this New York Soil Health Working Group, which is an interagency group of Soil Water Conservation District, New York Ag and Markets, New York NRCS, American Farmland Trust, different company partners, King's Agriseed, who you'll be hearing from today, innovative farmers. So we're really happy about the collaborative nature of this event. This is the sixth year that we've done something soil health related during when Empire Farm Days should have happened. Want to acknowledge a couple people behind the scenes of today's effort. Aaron Ristow of American Farmland Trust, Greg Albrecht helped get CCA credits for everyone, Paul Salon, and we're very appreciative of all the farmers that are taking the time out to be with us today and also on Friday. So with that, I'm going to show the slide briefly, the QR code that you can see for if you need CCA credits for today. If you have questions about that, you can email Greg or I, and we can send you this PDF so you can do that as well. There's two different options if you have the app or if you don't have the app. So another brief important thing, if you aren't already subscribed to the New York Soil Health listserv, I encourage you to subscribe. You can receive updates about different soil health events like this one today. And with that, I think we're getting ready to start. Today we have John Wallace, our keynote speaker. And after him at 11 a.m., we have a farmer panel on sustainable soil management strategies and dairy farming systems. So first up, we have John Wallace, who's an assistant professor at Penn State of weed science and agronomy, where I also got my master's and met him. He leads an innovative sustainable cropping systems research program aimed at developing cover crop strategies in full and reduced tillage systems. And he studies weed management and its relationship to cover cropping and different tillage practices. But today, John Wallace is going to focus on his cover crop interseeding work. So with that, I guess you can take it away.
All right. Can you share?
Yeah.
All right. Well, while you do that, thanks for the introduction, Joseph. I'm happy to be here and echo Joseph's sentiments. I'd love to be doing this in person, but I'm appreciative of Joseph and New York Soil Health for putting the time together to make a virtual event. I know it's still quite a bit of work. Here we go. All right. Can you see that now, Joseph? Can you see my screen?
Yep, I can see your screen.
Okay. All right, great. Okay, yeah. So so Joseph asked me to kind of talk a little bit about today about kind of what's going on with interseeding research in the Northeast, and so I need to take just a minute and acknowledge all the folks who have either previously led the research that I'm going to talk about today, or those who are contributing to the research that's going on. And so I did a postdoc at Penn State that started about 6 or 7 years ago, and was lucky to kind of join the tail end of a research project that was funded by the USDA CIG funding source. And that was led by my predecessor, Bill Curran, and Greg Roth, and Corey Dillon, and a number of agronomy extension team members at Penn State. as well as Matt Ryan, who most of you probably know at Cornell, and Stephen Mirsky's lab in Beltsville. And so that project was largely focused on kind of understanding and developing best management practices for interseeding cover crops into no-till corn production systems. And I was excited to talk about this today because it gives me an opportunity to introduce what's going on and what's going to be going on in both Pennsylvania and New York over the next 2 or 3 years. So we were fortunate to receive some Northeast SARE funding to focus on kind of advancing best management practices for interseeding cover crops. And so that team is myself, and I'm collaborating with Matt Ryan at Cornell, and the New York IPM program. Jamie Cummings and Brian Brown are participating, as well as a number of soil water conservation districts in New York and Pennsylvania. And I should acknowledge my research technologist, Tosh Mazzoni, who's really led the way in getting this project started in kind of a difficult, under difficult circumstances with the current pandemic. So I think everybody who's tuning in probably has thought about the promise and potential of interseeding cover crops into corn. And the figure on your left, that's the latest survey data from the NRCS on the percentage of grain crops where cover crops are integrated into those systems. And so you can see the Northeast, certainly there's a fair amount of cover cropping that's going on. Pennsylvania, the number is 37%. I think New York is very similar in the mid 30s. But that means that over 2/3 of grain crops are probably not seeing a cover crop post-harvest. And so I kind of think about interseeding in 2 ways. One, can we use interseeding practices to get more services, ecosystem services, in comparison to post-harvest seeding cover crops in those areas and regions and systems where post-harvest seeding works well. Alternatively, we have this great potential to get cover crops on more acres where it's really challenging to post-harvest seed cover crops. So certainly after corn taken for grain, or soybeans, even some cooler areas in the region, it's difficult to establish cover crops, maybe even after silage. And so there's a lot of potential for using interseeding to get cover crops on more acres in those scenarios. The other thing that's going to drive that is what is our goal for interseeding cover crops? So what services, ecosystem services or conservation benefits are we interested in? And so that's going to dictate the types of cover crops that we might want to interseed, how we might manage corn in the rotation and able to do that, how we may adjust our weed management programs. And so when we think about soil health principles or goals, or maybe regenerative ag principles, some people are calling that, providing continuous living roots, maximizing biodiversity, minimizing disturbance, maximizing soil cover, all those goals cover crop interseeding can potentially advance. So if I just step back and kind of look at where I see the real potential for interseeding, we in Pennsylvania as well as New York are farming on a fair amount of erodible lands. All right, so this is a great picture taken in the northern tier of Pennsylvania. Very picturesque landscape, but we're growing corn on a lot of hillsides in that country. And so certainly using conservation tillage practices is going to help with soil conservation and preventing erosion. But you can see this particular grower got a great catch from interseeding annual ryegrass. And he is set up really nicely going into that winter fallow period with having continuous living roots in the soil and really great protection from soil erosion. And so we typically think about soil conservation and soil erosion in those fallow periods, in those winter fallow periods. But in the Northeast, we think with changing precipitation patterns related to climate change, we're going to see more intense rainfalls that may occur early in the summer. And so certainly in tilled acres, having an interseeded cover crop can potentially limit the amount of soil erosion that might be occurring within the crop growing season. So this picture is taken from an organic cropping systems experiment at Penn State that I participate in, and we're interseeding annual ryegrass and forage radish and comparing that to some systems that don't receive an interseeded cover crop. And so those are two side-by-side plots right there shortly after one of those intense precipitation events where we got 1.5 inches or 2 inches in just a couple hours. And you can see that we're losing some soil downslope where we don't have the cover crop interseeded, and we're potentially limiting that where we do have the interseeded cover crop. I think the other area where there's a lot of potential for using interseeding to advance conservation goals is through improving nutrient management and really nitrogen management, and of course the long-term benefit in Pennsylvania and our region is improving water quality. And so, of course, we're using, where we have these crop livestock systems in the Northeast where we're using a lot of manure and need to manage manure. Having an established cover crop at the time of corn harvest makes manure management that much easier. And so this is another picture taken from that cropping systems experiment I was talking about at Penn State, where we got a great catch of interseeded annual ryegrass. And so that's what it looks like in the following spring. And so we can use species like annual ryegrass that really have great nitrogen scavenging and retention potential. So fibrous root systems that go pretty deep into the soil profile, and that's going to improve the retention of nitrogen and cycling of those nutrients in those systems. And then lastly, I think where there's a lot of potential is interseeding potentially facilitates introducing a lot more diversity, crop diversity into our rotations. And so one of the challenges in the Northeast, certainly after grain crops, is being able to establish legumes or really anything other than winter cereals in the fall. And so interseeding, we can potentially establish those legumes earlier and they'll be persist and overwinter better. We can also introduce brassicas, so we can introduce additional crop diversity that's going to likely improve soil health over the long term. Along those lines, there's a good bit of interest when we think about, crop rotation diversity and cropping systems diversity in using interseeded cover crop systems as a way to introduce livestock into those rotations. So really, truly integrated livestock crop rotations where instead of cows just grazing corn stover post-harvest, if we can have an established cover crop where cattle can be grazing, and have a good source of forage out there in addition to that stover. That's something that I know there's a good bit of interest right now. Okay, so those were just a couple areas where I think there's just a lot of room for growth and adoption with interseeding. But it's going to be really helpful for me and my program and this Northeastern SARE project that we're just starting to get a better understanding of what your interests are. And so I asked Joseph to put up a couple poll questions. Certainly if you're a farmer and you do or do not have experience, that's great. We want to hear from you. If you're an ag service provider or working in some kind of support industry, just answer these questions kind of based on your perception of what might be the challenges or opportunities in your growing region. So the first question is just to get an idea of what the level of experience with interseeding is. So if you guys could go ahead and choose one of those. The second question, I've listed some of those potential benefits and opportunities that interseeding creates, and I'd like to hear what everybody thinks about those, what really interests you about interseeding, and you can check more than one if you have multiple interests. And then along the same lines, hopefully if you scroll down on your screen, the last question is about what the challenges are. And so maybe if you have experience that you're speaking firsthand, if you don't have experience, maybe you're just thinking about the perceptions and thinking through how what might be the challenges to start interseeding on your farm. So I'll just wait for maybe a minute or two and let the answers roll in here.
John, do you want me to show this poll? I could share the screen of.
Yeah, I mean, I think if you could, if we could get a quick snapshot of what the poll results are, that would be great. I think that would potentially maybe encourage some more questions or discussions at the end of the talk.
Looks like we got 39 responses so far.
All right, maybe just give it a little bit more time. Maybe some folks aren't able to weigh in, perhaps if they're just listening on the phone or something. All right. Okay, Joseph, I think we may as well go ahead and wrap that up if you're able to do that.
Are you able to see these polls, or are you just seeing my desktop?
I can see the poll, I think.
Okay.
So, yep, I can see the first two questions. We can't see the third.
Okay. Okay.
So it looks like for the first two questions, it looks like you know, most people don't have first-hand experience. We do have some folks that are trying this. The second question, it looks like everybody's interested in the soil conservation and soil health benefits. Those are kind of catch-alls. So certainly we would anticipate that. And then could you scroll down, Joseph, to
Yeah,
look at the number
on
3?
mine it shows I can see it all, so that's having
Oh,
problems.
I can scroll.
Okay,
Yeah.
cool.
Yep. And so the third question, so one of the biggest limitations, it looks like, is the lack of specialized equipment for drill seeding, which is certainly a big deal, right? There's certainly, that's a big barrier to adoption, is lacking the equipment needed to do it. Okay, so can I go back to sharing my screen? I think I can do that. Okay, are we back to mine then?
Yeah.
Okay. All right. Well, thanks everybody for weighing in. That is helpful, certainly, and that'll help inform kind of a lot of the outreach and extension programs that we're going to try to put on in the next couple of years. Okay, so I want to transition into, for those folks who maybe don't have a lot of experience or maybe haven't been following interseeding as closely, what we considered just a few kind of best management practices that were developed in that earlier research I spoke about that was conducted in the Northeast. and then really kind of what we've observed from those early adopters. All right, and so the first thing is you know, people mentioned the lack of specialized equipment, right? So we're drill interseeding and we're using high clearance grain drills to do that. So that's different than just using a regular grain drill that you might be seeding small grains with. And of course, at Penn State, we've been using the Penn State Interseeder, which is now Interseeder Technologies, and that's what you're looking at is how those are designed. There are other models and makers of interseeding equipment now, but generally the concept is you have a high clearance grain drill and you're interseeding either 2 or 3 rows between a 30-inch corn stand and typically on a 7.5-inch spacing. And certainly in no-till systems, it seems like there's a benefit and a pretty dramatic benefit to getting seed in the ground consistently. And so that really increases establishment rates because you have better seed to soil contact in those no-till systems. In New York, there's, you know, there's a fair, in comparison to Pennsylvania, there's probably more tillage-based systems. And so we have done some work as part of an organic project that was funded by the OREI program. And we were on several organic grain farms where we compared drill interseeding to just broadcast interseeding at last cultivation, which historically and maybe in some parts is still a fairly routine practice. And so just broadly speaking, what we took away from those from that research was that certainly the method of establishment influences the expression of the cover crop. However, when we just look at kind of total biomass production, establishment rates, what you're getting at the end of the season, we found that there was really only a marginal benefit to drill interseeding in comparison to broadcast interseeding. And where we did see the benefit was at the sites and the years in which we were a little bit drier and suffered through some periods of kind of semi-drought conditions. Right? And so in those cases, there was a benefit to getting that seed in the ground and getting better seed to soil contact. The other thing that is really important to kind of optimizing interseeding is when you're going to interseed relative to the corn growth stage. And so you can either think about this as the corn growth stage, how many collars, or potentially how big that corn is or how many weeks after you've planted. And so what I'm showing is just some results from a 2-year study conducted at State College where cover crops were interseeded at every collar from V2 through V6. And we took yield, corn yield, and we took cover crop biomass at the end of the growing season. So the goal here in identifying the appropriate corn growth stage for interseeding is to minimize the potential for a yield drag due to if you're interseeding too early and introducing too much competition, you potentially could end up with a yield drag. So we're trying to minimize that potential and maximize the corn or the cover crop growing season. So if we're not taking a yield drag, there seems likely that we're going to see a benefit from interseeding earlier so we can extend the period of time in which that cover crop is established. And so what this work showed was you can interseed too early, so that we did see a yield drag at V2, and though not statistically, it looks like somewhere between V3 and V4 you start to you know, not see less competition and not see the yield drag. So kind of what came out of this research was a consensus that kind of the window for interseeding was somewhere between V4 maybe through V6. If you were to interseed later, you'd be running into trouble as far as the corn getting too big and not being able to get the drill through the field. And you would also be really shortening the amount of time in which the cover crop had good light resources. And so you'd be shrinking that time from cover crop interseeding to corn canopy closure. The other thing is, so not all cover crops are created equal for this type of approach, right? So there needs to be some shade tolerance with these cover crop species. And so what kind of came out of the early research was annual ryegrass, no matter what cultivar or variety, seems to be well adapted for this type of approach. It's a consistent performer, and out of all the grass cover crop species, it's the most consistent performer. We've also tried orchard grass, which seems to be shade tolerant. Out of the legumes, medium red clover and crimson clover do well. Forage radish or daikon radish also can do well in these types of systems. Now, since this research and since we've seen some early adoption occur out on the landscape, we've seen a lot more and different cover crop species being utilized. And so certainly, you know, there would be some benefits to making cereal rye work in these systems. It'd be a nice to establish cereal rye in that corn and prior to a soybean crop. Cereal rye is a lot easier to manage than annual ryegrass as far as terminating it chemically with herbicides. And so we've seen some successes and some failures with cereal rye. So there's probably some more work to do to find other grass cover crops that can work in these systems. There's other legumes that are being interseeding right now. I'm going to talk a little bit later in the talk about wide row interseeding. And so there's, rather than cool season legumes, I'm seeing some successes as well with people using more summer annual legumes, things like cowpea or sun hemp. And so this is by no means a restrictive list. It seems like people are trying different cover crop species with some success. Okay, the other important best management practices, and this is really was the focus of my research as a postdoc and remains a focus of my program now, is understanding how we put together a herbicide program that's going to provide some weed control but still facilitate the use of interseeding practices. And so basically what we're looking for is in a no-till system, if you're able to use a very simple program with no residual herbicides and just come in Roundup Ready corn and make a glyphosate pass just prior to interseeding, that would be ideal. Certainly, it's becoming more and more challenging to use that type of herbicide program. We have glyphosate-resistant weeds that we're dealing with, and then it's just a better best management practices, and you're going to be more successful with post-herbicides, including glyphosate, if you're using a herbicide program that has residuals. And so what our early research was focused on the question of, if I want to interseed a certain cover crop, what herbicide programs can I use that don't cause injury to that cover crop? And broadly speaking, we're able to identify a few what we would call short-lived or light residual herbicide programs. And by that, I mean that these residual herbicides provide some weed control early in the corn growing season. We maybe get 2 or 3 weeks of residual activity, but they dissipate in the soil profile below phytotoxic levels prior to interseeding. And so a lot of that work, we were interseeding around V5 or so, 42 to 50 plus days after planting or after that residual herbicide application. And so this is going to change the persistence of residual herbicides in the soil. Is going to be a function of environmental conditions or growing conditions. So how much rain you've received, how warm the soil is, so how much microbial activity you have in the soil to break down those herbicides. It's also going to change along soil texture, right? So whether you're in a heavier or a lighter soil texture, that's also going to dictate how long those herbicides persist in the soil. So generally speaking, for our silt loam soils in Pennsylvania in no-till systems, we've been able to use with pretty good success light herbicide programs like Verdict or some combination of products that are going to provide a little bit of grass control as well as some broadleaf control, but break down prior to interseeding. Okay, so if you put all those together, generally speaking, what kind of the early best management practices were you might potentially use a short-lived residual herbicide that's going to provide a couple weeks of weed control, and that's going to set your glyphosate application post. It's going to be more successful, and then you would come in right behind that glyphosate pass and interseed, and you might do that between V4 to V6. And if you do that, you're limiting the potential for a yield drag. You're also hopefully allowing enough time for that cover crop to be established before before the corn canopies. And so typically what we see is, once the corn canopies, we see growth rates of that cover crop really slow down. And the challenge then is for that cover crop to persist under that amount of environmental stress underneath that corn canopy. Low light conditions, potentially less soil moisture available, and through that hot period of the summer. And so persistence has really been the biggest challenge, and it's been not as much about establishment of the cover crop, but more about persistence of that cover crop through that more stressful part of the growing season. Okay, so so I just want to talk about what we've seen kind of across the Northeast. And so again, what we see is really the challenge is how do we get to more consistency out of interseeded cover crops? And so the figure on your right that shows a series of on-farm interseeding trials that was conducted as part of the NRCS-CIG grant. And so the points or the bubbles are locations of an on-farm trial, and the size of the bubble is the amount of fall biomass production that was collected at the end of that trial. And so you can see the incredible amount of variability that we see. So 50 pounds per acre, you might probably consider that as a failure. 1,000 pounds of dry matter biomass production per acre at the time of harvest or in late fall is probably considered a success. And so how do we get more success than failure? And so we've been thinking about and kind of observing what's going on, with early adopters and trying to identify sources of variability. And so certainly it seems like in certain, plant hardiness zones in warmer regions, say in Lancaster in Pennsylvania, it's much more challenging to really establish a cover crop and have it persist through that later part in the growing season. We do see some differences in successes when it comes to systems. So in dairy systems where you're growing corn for silage and you're interseeding, you probably also have a history of manure use, so you probably have just a higher pool of nitrogen availability in those systems. We tend to see a lot more success than in systems where you're just growing corn for grain. And then finally, what we're really trying to do is identify those constraints related to both systems environment, but also address potential in-season management issues where we can improve the consistency of interseeding. And that's really the focus of what I want to talk about for the rest of the talk. So this is, if we just take a step back and think about what's going on in an interseeded system and think about kind of the crop ecology and what the potential limiting factors could be. This is a nice, the figure that you're looking at is a summary of a nice study that was conducted by Matt Ryan's group at Cornell, and it was experiments were conducted at Cornell, Penn State, and in Maryland. And what that study focused on was understanding kind of light resource dynamics. And so what they were doing was interseeding corn at varying levels of density, and they were using flex-ear hybrids as well, with the idea that there may be you may be able to lower your seeding rate, your corn population, if you're using a flex-ear hybrid and allow more light to penetrate into that canopy for longer to allow that cover crop to establish and persist without taking a yield drag. And so what their research showed was indeed when you lower the corn density, as you would expect, you're increasing light transmission. And when you do that, you are seeing an increase in cover crop biomass production. And so that makes sense. But what this study also highlighted, and what's going to be challenging when we think about how to introduce more light into that canopy to allow those cover crops to persist, is you're also potentially introducing additional weed pressure, right? So when we're lowering corn densities, just in general, more available resources, they were seeing a response with greater weed biomass production in those systems. And in turn, when you're introducing more weed pressure, you're then introducing a competitor with that interseeded cover crop biomass. So weed pressure might be limiting the establishment and persistence of the cover crops in those types of systems. And so I've been thinking quite a bit about ways we can both address kind of the light resource question, as well as the challenges related to weed management when we're making those types of adjustments. And so here's just a couple more pictures. This is a picture of annual ryegrass. You know, you can see the corn leaf. So this is at dry down, maybe early September. And this is often what annual ryegrass looks like. So annual ryegrass was established, it was doing quite well, and then it was under that corn canopy in that more stressful period in August. And you see some sloughing off, but it's at least persisting. And once that corn canopy opens up, and we see regrowth and we see growth coming on in that fall growing period. And so while annual ryegrass is able to persist, some other species may not be able to persist. And so if we want to introduce more diversity into our systems when we're interseeding, we're probably going to need to address kind of that light resource and those environmental stress factors. Okay, so what I want to talk about now is I don't have a lot of data to share. This is really the direction, the next steps, what I consider the next steps to be to kind of improving the performance of interseeding across the board. And so these are some of the things that we're just now starting to look at in studies with this Northeastern SARE project. So if we just think about improving light resource management and able to facilitate increased performance of interseeded cover crops, we can think about light resource in either space or in time. And so when we think about making adjustments to corn management, that's an opportunity to kind of change the spatial component of those light resources. And so Matt Ryan's study that I shared, that particular study looked at the use of flexier hybrids and lower plant populations, and they found that you could reduce plant populations by 10 to 15% and still not take a yield drag, and you are making some improvements in the amount of light and light quality that's getting into that canopy. And you can see some positive responses on the performance of interseeded cover crops. The other thing is to explore the crop genetics or the corn genetics that we have available to us, and find and select for varieties that have architecture that's going to facilitate greater light penetration into the canopy. So more upright leaf architecture, for example. And then finally, the most drastic change to your corn management could be what might have the greatest bang for your buck or improvement when it comes to interseeder performance is to move to wider row corn. And so there's a lot of interest right now and some early research going on comparing 30 versus 60-inch corn and interseeding performance. Certainly, it doesn't need to be 60. You know, we used to plant corn on 36-inch rows or 40-inch rows. You know, with enough willingness to adapt planters, we could potentially find the row spacing that really gets at that balance between yield and also interseeded cover crop performance. On the cover crop management side, when it comes to light resources, really the biggest thing we can do is think about the temporal aspect of that. So my thinking is that the earlier we interseed relative to corn canopy closure, the greater amount of time that provides for that cover crop to establish a root system, above ground biomass production, and the more time that we have for root establishment to occur, the greater the potential for that cover crop to persist through those stressful conditions. And so that's the other area I think that we can potentially explore to improve cover crop interseeding, is to really push interseeding up to maybe the V3 corn growth stage pretty consistently. So that's, we're going to address some of those questions, and we're combining some of those practices in an experiment that just got started this year. So I don't have really data to share, but they are off and underway. So there's an experiment that's being conducted at Cornell, at Rock Springs, where State College is, and at our Landisville Research Station in Lancaster, which gives us a nice latitudinal gradient and different growing conditions to look at these different in-season management practices. And so we're looking at corn varieties, or the corn genetics, so flex year versus determinate years, that are going to have a little bit different architecture on 30 or 60-inch row spacing. We're also looking at interseeding early at V3 compared to V5 or V6 or even later. And then we're looking at the different responses for some of the cover crops that we know work in these systems. And so here's just a couple pictures. Again, these pictures, I was looking at them last night, they don't maybe seem real dramatic, but we do, when we're out there, we see some differences in kind of the crop canopy architecture between the different varieties, so the semi-flex versus the determinate ear. And so that's a picture of it on 30-inch row spacing. Here's a picture of our studies at Landisville on 60-inch row spacing. And so you can look forward to hearing about some results this winter as far as cover crop performance goes. Let's see, I think I probably need to wrap up here in a few minutes, but I want to talk a little bit about what's going on with our weed control or weed management research when it comes to interseeding. And so from a weed scientist standpoint, what I see the real challenges is that glyphosate only programs really limit the potential of interseeding. So certainly we're experiencing pressure from glyphosate resistant weeds, but if we're going to interseed early and apply glyphosate early, we're also potentially dealing with just late escapes of maybe fall grasses, things like crabgrass or fall panicum, or late emerging summer annuals like the pigweeds. If we do push up interseeding to even earlier in the corn growing season, maybe a month after applying a residual product, that provides even less of a window for those products to break down. And so that's going to make using even setup programs or lighter residual herbicide programs even more difficult. So what I think a couple of the opportunities is we know generalities about cover crop tolerance to herbicides. We don't know specifics, and so there is a little bit of room for exploration to be able to find some cover crop tolerance of specific species to specific herbicide programs. And if we can identify some combinations of herbicides that are compatible with specific cover crop species, that can potentially provide a lot more flexibility in how we use those herbicides. There's also an opportunity, I think, to make more use out of residual herbicides that don't have any post-emergent activity. So if you're going to interseed early after the cover crop established, there's a class of chemistry, the group 15 herbicides that provide annual grass control and control of small seeded broadleafs that have no post-emergent activity that we might be able to apply over top of an interseeded cover crop. and extend weed control later into the season. So my current research program kind of flips the question that we were previously addressing, and we're asking if you need herbicide program X to maintain weed control in your system, then what cover crops can you potentially establish using interseeding practices while still using that necessary herbicide component? And so I've been conducting several greenhouse experiments, ongoing greenhouse experiments, and what we're doing is we're looking at potential areas where we see, where we're likely to see variation in herbicide sensitivity to cover crops. So we know that cover crops are going to differ in their sensitivity to herbicides based on taxonomic groups, whether they're grasses, legumes, or brassicas. But in weed control, we often see herbicides differ in their control levels based on weed seed size, right? And so that's also an area in which we can explore. Are larger seeded cover crops potentially more tolerant to certain herbicides? So we see, for instance, a lot of variability in seed size with the legumes that we might interseed. So there's a big difference between Austrian winter pea and hairy vetch and crimson clover. So that we may be able to safely interseed something like hairy vetch or Austrian winter pea when we're not able to successfully interseed clovers. So that's the type of work I'm doing. And I think I'm already over time. And so rather to get into more detail when it comes to those herbicide approaches, I think, Joseph, I'm going to skip to just the last couple slides here and summarize. And then I wanted to ask one follow-up poll question. And so I hope this kind of gave you a snapshot of what we think works when it comes to interseeding and some of those best management practices. And then, where I think we might need to go and where some research will help, but also some willingness for those early adopters and people interested in this practice to start to think about adapting their system and trying new things on their farm when it comes to interseeding. So certainly addressing this light resource management question to make cover crops more successful when it comes to establishment and persistence. So through different corn management or cover crop management practices, as well as starting to address weed management questions with a little more detail about finding compatible herbicide residual programs that we're going to need probably to maintain weed control and no-till systems, but also potentially allow for cover crop interseeding to occur. Last thing I wanted to note is I'm gonna provide my email here in the next slide. There's an on-farm component that's also gonna provide us some opportunities to have some co-learning events and extension meetings over the next couple years for this Northeastern SARE project. And so we're gonna have sites both in New York and in Pennsylvania. And we're going to have some simple on-farm strip trials, and we're coordinating and working with soil water conservation districts that do have interseeder grain drills, either for loan or for a small fee-for-service program. And so that's a great opportunity for folks listening to today who said that the equipment limitation was the biggest factor that prevents them from interseeding to be able to try it on their farm. And so hopefully this project will allow some people to try interseeding for the first time and see how they might be able to adapt interseeding to their production system. So if you are interested in that, or if you're just interested in following along, and seeing the research results and learning about opportunities for coming to a field day or a co-learning opportunity, I'm going to leave this up here. You can send me a quick note, and we're going to create a listserv, which isn't quite up yet, but we'll have a listserv where you can we can notify you of those opportunities. So Joseph, could you put up that last set of poll questions?
Yep, here they are.
Okay. So, what we're looking at, what I want to know is when we're talking about adjustments that we might make to facilitate greater performance of interseeded cover crops, what's your willingness to try new things? And so I have a couple questions related to that. And then also want to gauge folks' interest in trying interseeding on your farm over the next couple of years.
And if you guys have questions, you can ask a couple questions through the Q&A. We'll probably have enough time for 1 or 2 questions.
Maybe while folks have a chance to fill out those survey questions, Joseph, if there are any questions in the chat box, I'd be happy to try to address as many as possible.
There was one question, you kind of addressed a little bit of it, but I'll just say the whole thing. What is influencing the factor behind lack of interseeding success in high yielding corn? Is it sunlight and or moisture? What would a cutoff high yield to be concerned at be? So maybe the second part of that, if you thought
yes.
about.
So we've had a lot of, so this question has been brought up informally amongst interested parties quite a bit, that, you know, we do see differences in success kind of along hardiness zones, and related to that is yield potential, right? And so, you know, I've heard if your yield potential is north of 200 bushels, it's probably more challenging to make interseeding successful. And the reasons, well, I think it's you know, you're probably planting at a little bit of higher population. The genetics are probably going to be a little bit different in comparison to a real silage variety. So, you know, you're probably getting to canopy closure quicker, and that canopy closure might be more intense. So, you know, that's my best guess. And what we're really hoping to do is to be able to get enough small on-farm trials, kind of strip trials conducted across a lot of different production systems, and from southern Pennsylvania through New York, where we can start to get at that question. So if we just, you know, if we have a small strip trial that has a similar cover crop seeded and the same kind of management, we can potentially get at that question, is what is the relationship between yield potential and interseeding success?
Great, that was a great answer. We have another question. Are you quantifying soil erosion loss from interseeded research plots? And are you observing water or nutrient competition between corn and cover crops ever?
Yeah, so 2 great questions. So I know of, we do not have data on actually quantifying soil erosion loss, or, you know, T, if you're thinking about kind of the Russell model. There's been some great work in a totally different type of production system in sweet corn in Oregon. A colleague, Ed Peachy, who's been interseeding cover crops into sweet corn, has quantified that. One of our projects, not the Northeastern SARE project, we are going to actually try to quantify soil erosion loss in interseeded versus uninterseeded systems in an organic tillage-based system. The second question, so yeah, I talked about light resource, right? And so the other co-limiting factors that take place after corn canopy closure is both for either nitrogen or nutrients, as well as soil moisture. And so I think in a year like this year, so in our current interseeder experiment, when you have full canopy closure, the other thing, depending on leaf architecture, that happens is that you know, that corn crop is catching more precipitation and funneling that precipitation down into the in-row zones, away from the interrow zones where your cover crop has been established. So I do think that that is an important potential limiting factors in years like we're having this year. So last year when we interseeded, we had timely rains all through the summer. And so, you know, it just wasn't a limiting resource, but it definitely potentially can be.